Imagine stepping aboard a spacecraft that defies everything we know about physics, a vessel capable of traveling faster than light itself. In an instant, you could journey to Alpha Centauri, explore the mysteries of distant galaxies, or witness the birth of stars in nebulae thousands of light years away. Today, we're embarking on a mind-bending exploration of faster-than-light travel, diving into cutting-edge physics, theoretical possibilities, and the profound implications for humanity's future among the stars. Let's get started. As objects accelerate toward light speed, something extraordinary occurs. Their mass increases according to Einstein's equations, approaching infinity as velocity approaches the speed of light. This means that accelerating any object with mass to light speed would require infinite energy, more energy than exists in the entire observable universe. It's not just a technological barrier, it's a fundamental law of nature that seems to protect the causal structure of spacetime itself. Time dilation presents another mind-bending aspect of near-light speed travel. As you approach the cosmic speed limit, time itself slows down relative to the outside universe. At 99% of light speed, time would pass 7 times slower for you than for observers on Earth. At light speed itself, time would stop completely from an external perspective, while from your viewpoint, the journey would be instantaneous regardless of distance. Length contraction adds another layer of strangeness. Objects moving at relativistic speeds contract in the direction of travel. At light speed, this contraction becomes infinite, meaning the object would have zero length in its direction of motion. The very concept of three-dimensional objects traveling at light speed becomes meaningless. The Doppler effect would transform your perception of the universe in spectacular ways. Light from stars ahead of you would be blue-shifted to higher frequencies, potentially becoming deadly gamma radiation. Meanwhile, light from behind would be red-shifted toward longer wavelengths, eventually becoming undetectable. The familiar starscape would be replaced by a narrow cone of intense radiation ahead and darkness behind. But let's imagine we could somehow overcome these barriers. What would faster-than-light travel actually look like, and how might it be achieved? Science fiction has given us warp drives, hyperspace jumps, and teleportation. But what does real physics suggest about these possibilities? If you're finding these cosmic concepts as fascinating as I am, I'd really appreciate it if you could hit that subscribe button and give this video a thumbs up. We're just getting started on this journey through the most mind-bending possibilities in physics, and your support helps me continue exploring these incredible frontiers of science. The Alcubierre warp drive, proposed by physicist Miguel Alcubierre in 1994, represents one of the most scientifically grounded approaches to faster-than-light travel. Rather than moving through space faster than light, this concept involves warping space-time itself. The drive would contract space in front of the spacecraft while expanding it behind, creating a warp bubble that carries the vessel along at effective speeds faster than light. The beauty of the Alcubierre drive lies in its respect for Einstein's relativity. The spacecraft itself never exceeds light speed locally. It's carried along by the expansion and contraction of spacetime. This is similar to how cosmic inflation allowed regions of the early universe to separate faster than light through the expansion of space itself without violating relativity. However, the Alcubierre drive faces enormous practical challenges. The original calculations suggested it would require exotic matter with negative energy density, something that may not exist in nature. The energy requirements were initially estimated to exceed the mass energy of the observable universe, making the concept seemingly impossible to implement. Recent refinements by physicists like Harold White at NASA's EagleWorks laboratory have reduced these energy requirements significantly. By optimizing the warp bubble geometry and thickness, White's calculations suggest that the energy needed might be reduced to the mass energy equivalent of a large spacecraft rather than an entire universe. While still enormous by current standards, This brings the concept into the realm of theoretical possibility. Wormholes represent another fascinating avenue for faster-than-light travel. These hypothetical tunnels through space-time could connect distant regions of the universe, allowing travelers to take shortcuts that effectively enable faster-than-light journeys. Einstein and Nathan Rosen first described these structures in 1935 as solutions to the equations of general relativity. Traversable wormholes, as opposed to the non-traversable Einstein-Rosen bridges, would require exotic matter to keep them stable and open. Without this exotic matter, the wormhole would collapse faster than anything could pass through it. The exotic matter would need to have negative energy density, creating a repulsive gravitational effect that counteracts the wormhole's natural tendency to collapse. The concept of extra dimensions, fundamental to string theory and other unified theories of physics, opens up additional possibilities for faster-than-light travel. If our three-dimensional space is embedded in higher dimensional space, it might be possible to take shortcuts through these extra dimensions, similar to how a two-dimensional ant could take a shortcut through three-dimensional space by traveling through the air rather than along a curved surface. Quantum entanglement presents perhaps the most mysterious phenomenon that appears to involve faster-than-light effects. When particles become entangled, measuring one instantly affects its partner regardless of the distance separating them. Einstein called this spooky action at a distance, and experiments have confirmed that these correlations occur faster than light could travel between the particles. However, quantum entanglement cannot be used for faster-than-light communication because the correlations appear random until compared. You cannot use entanglement to send information faster than light, which preserves causality and prevents paradoxes. Nevertheless, some theoretical proposals suggest that quantum entanglement might be harnessed for faster-than-light travel through mechanisms we don't yet understand. The many-worlds interpretation of quantum mechanics suggests that every quantum measurement splits the universe into multiple parallel realities. Some speculative theories propose that faster-than-light travel might involve jumping between these parallel universes, effectively taking shortcuts through the multiverse. While highly speculative, this concept illustrates how quantum mechanics might provide pathways around classical limitations. Tachyons, hypothetical particles that always travel faster than light, represent another theoretical possibility. If tachyons exist, they would have imaginary mass and would experience time running backward. While no tachyons have ever been detected, their theoretical properties suggest they could enable faster-than-light communication and travel, albeit with severe causality problems. The search for tachyons continues in particle accelerators and cosmic ray detectors around the world, but their absence from our observations might actually be protecting the universe from causal paradoxes. If tachyons existed and could carry information, they would allow messages to be sent to the past, creating grandfather paradox scenarios that could unravel the logical structure of reality itself. The concept of closed time-like curves emerges naturally from general relativity under certain extreme conditions. These are paths through space-time that loop back to their own past, potentially allowing time travel and, by extension, faster-than-light effects. Rotating black holes, cosmic strings, and other exotic objects could theoretically create such curves, though the energy requirements and stability issues make them impractical for travel. Quantum tunneling offers another intriguing possibility that seems to violate the light-speed barrier. In quantum mechanics, particles can tunnel through energy barriers instantaneously, appearing on the other side without spending time in the forbidden region. Some interpretations suggest this process occurs faster than light, though careful analysis shows that no information actually travels superluminally during tunneling. The EPR paradox, proposed by Einstein, Podolsky, and Rosen, was intended to show that quantum mechanics must be incomplete because it allows instantaneous correlations across arbitrary distances. However, Bell's theorem and subsequent experiments have confirmed that these correlations are real and fundamental to quantum mechanics, not evidence of hidden variables or incomplete theories. Speaking of the fundamental barriers to high-speed travel, the challenges we face aren't just theoretical, they're built into the very fabric of reality. If you're curious about why even approaching light speed presents insurmountable obstacles, you should check out my video called The Harsh Reality of Why We Can't Travel at Light Speed. It explores the brutal physics that makes relativistic travel not just difficult, but potentially lethal, revealing why the universe seems designed to keep us trapped in our cosmic neighborhood. The link is in the description and pinned on the comments. But let's imagine we've somehow overcome these barriers and achieved faster-than-light travel. What would the experience actually be like? The journey itself would be unlike anything in human experience, challenging our fundamental understanding of space, time, and causality. If you were aboard an Alcubierre warp-drive spacecraft, the experience might be surprisingly mundane from your perspective. Inside the warp bubble, space would be flat and normal. You wouldn't feel any acceleration or unusual forces. The exotic physics would be happening outside your local reference frame, in the warped space-time surrounding your vessel. However, the view outside would be spectacular and strange. The normal star field would be replaced by a complex pattern of distorted light, as photons from distant stars are bent and focused by the warped space-time around your ship. Stars ahead might appear as brilliant points of concentrated light, while those behind could be stretched into long streaks or become completely invisible. The Doppler effects in a warp bubble would be even more extreme than those experienced during normal relativistic travel. Light from your destination would be compressed into a narrow cone of intense, blue-shifted radiation directly ahead. This radiation could be so energetic that it would be lethal to any unshielded observers, requiring sophisticated protection systems. Communication with the outside universe would present unique challenges. Radio signals sent from within the warp bubble would be severely distorted by the warped space-time, potentially making them unrecognizable to outside observers. The time dilation effects, while different from those in special relativity, could still create significant communication delays and synchronization problems. Wormhole travel would offer a completely different experience. The journey through the wormhole throat might involve passage through regions of exotic space-time geometry where the normal rules of physics are suspended. Tidal forces could stretch and compress your body in ways that would be fatal without advanced protection systems. The visual experience of wormhole travel would depend on the specific geometry of the wormhole. Some theoretical models suggest you might see the entire history of the universe compressed into a brief moment as you pass through the throat. Others propose that the journey would be instantaneous from your perspective, with no subjective experience of travel time. Navigation through a wormhole network would require unprecedented precision. Unlike normal space travel, where small course corrections can be made continuously, wormhole travel would be more like threading a needle at cosmic scales. Missing your target could send you to completely unintended destinations, potentially in different regions of space or even different times. The quantum mechanical aspects of faster-than-light travel would introduce additional complexities that we're only beginning to understand. Quantum field theory in curved space-time becomes extremely complex when dealing with the exotic geometries required for superluminal travel. Virtual particles, vacuum fluctuations, and other quantum effects could behave in unpredictable ways. Hawking radiation, normally associated with black holes, might also occur around warp drives and wormholes. The extreme curvature of space-time could create conditions where particle-antiparticle pairs are separated, leading to the emission of real particles and radiation. This process could drain energy from the propulsion system and create additional hazards for travelers. The information paradox that plagues black hole physics might also apply to faster-than-light travel. If information can travel faster than light, it could potentially violate the fundamental principles of quantum mechanics that require information to be conserved. Resolving these paradoxes might require new physics that we don't currently understand. Quantum entanglement-based travel, while highly speculative, would involve manipulating the fundamental correlations that connect particles across space. This might require technologies that can create, maintain, and manipulate entangled states on macroscopic scales, capabilities that are far beyond our current understanding of quantum mechanics. The energy requirements for faster-than-light travel would be staggering regardless of the method used. Even the most optimistic calculations for warp drives require energy equivalent to the mass of large planets or stars. Wormholes would need similar amounts of exotic matter to remain stable. These energy scales are so enormous that they challenge our understanding of what's physically possible. Antimatter, often proposed as a fuel source for advanced propulsion systems, would be inadequate for faster-than-light travel. Even perfect matter-antimatter annihilation, which converts mass to energy with 100% efficiency, couldn't provide the exotic negative energy required for warp drives or wormhole stabilization. Zero-point energy, the quantum vacuum energy that exists even in empty space, has been proposed as a potential energy source for exotic propulsion. However, extracting usable energy from the quantum vacuum faces fundamental thermodynamic barriers. The Casimir effect demonstrates that vacuum energy is real, but harnessing it for propulsion would require technologies that may violate basic physical principles. The exotic matter required for faster-than-light travel would need to have properties that don't exist in any known form of matter or energy. Negative energy density, negative mass, or other exotic properties would be necessary to create the space-time geometries required for superluminal travel. Whether such matter can exist in nature remains an open question in theoretical physics. Dark energy, which drives the accelerating expansion of the universe, represents a form of energy with repulsive gravitational effects similar to what would be needed for warp drives. However, dark energy is extremely diffuse and cannot be concentrated or controlled with any known technology. Understanding dark energy better might provide insights into exotic matter, but practical applications remain far in the future. The technological challenges of building faster-than-light spacecraft would dwarf anything humanity has ever attempted. The precision required to manipulate space-time geometry or create stable wormholes would exceed our current capabilities by many orders of magnitude. Every component would need to function perfectly in environments where the normal laws of physics are pushed to their limits. The technological challenges extend beyond just the propulsion system to every aspect of spacecraft design. Navigation systems would need to account for the non-linear behavior of space and time around the vessel. Traditional concepts of position, velocity, and acceleration would become meaningless in regions where space-time itself is being manipulated. The spacecraft would need sensors and computers capable of operating in environments where causality itself might be distorted. Life support systems would face unprecedented challenges in faster-than-light spacecraft. The exotic fields required for superluminal travel could interfere with biological processes in ways we can't predict. The electromagnetic fields generated by warp drives might disrupt neural activity, cellular metabolism, or DNA replication. Protecting human occupants would require shielding technologies that don't currently exist. The psychological effects of faster-than-light travel would be equally challenging. Human consciousness evolved in a universe where cause precedes effect and time flows in one direction. Experiencing regions where these fundamental assumptions break down could have profound psychological consequences. Travelers might experience temporal disorientation, causal confusion, or other mental effects that we can't anticipate. Communication systems would need to function across regions of severely distorted space-time. Radio waves, which normally travel at light speed, would be affected by the exotic geometries around faster-than-light spacecraft. Maintaining contact with Earth or coordinating with other vessels would require communication technologies that can operate in environments where the normal rules of electromagnetic propagation don't apply. The safety systems for faster-than-light spacecraft would need to account for failure modes that don't exist in conventional vehicles. A malfunction in a warp drive could potentially create a black hole, tear a hole in spacetime, or trigger other catastrophic events. Emergency procedures would need to address scenarios where the spacecraft becomes trapped in exotic spacetime geometries or lost in regions where normal physics doesn't apply. Material science would need to advance dramatically to create structures capable of withstanding the stresses of faster-than-light travel. The exotic fields and forces involved could affect matter at the atomic level, potentially causing structural materials to behave in unexpected ways. Spacecraft hulls would need to maintain their integrity in environments where the fundamental forces of nature are being manipulated. The environmental impact of faster-than-light travel could be enormous on cosmic scales. Warp drives might leave permanent distortions in spacetime that could affect other spacecraft or astronomical objects. Wormholes could potentially destabilize if not properly maintained, creating hazards for future travelers. The energy expenditures involved could affect the local space environment in ways that persist long after the spacecraft has departed. Quality control and testing for faster-than-light propulsion systems would present unique challenges. How do you test a warp drive without risking the destruction of your test facility or the surrounding region? Computer simulations would be essential, but they would need to model physics that we don't fully understand. The first attempts at faster-than-light travel would necessarily be experimental, with unknown risks and consequences. International cooperation would be essential for developing faster-than-light travel technology. The resources required would exceed the capabilities of any single nation, and the potential risks would affect all of humanity. Establishing international protocols for faster-than-light travel would require unprecedented cooperation and agreement on safety standards, environmental protection, and technology sharing. The economic implications of faster-than-light travel would be revolutionary. The ability to reach other star systems in reasonable timeframes would open up possibilities for interstellar trade, resource extraction, and colonization that are currently impossible. The economic benefits could justify the enormous development costs, but the initial investment would require global cooperation and commitment. Space law would need to be completely rewritten to address faster-than-light travel. Current space law is based on the assumption that travel between star systems takes many years or decades. Faster-than-light travel would make interstellar jurisdiction, property rights, and territorial claims much more complex. New legal frameworks would be needed to govern activities across multiple star systems. The detection and tracking of faster-than-light spacecraft would require new technologies and methods. Traditional radar and optical tracking wouldn't work for objects that can appear and disappear faster than light can travel. Space traffic control would need to account for vehicles that can traverse vast distances instantaneously, potentially creating collision risks that are impossible to predict or prevent. Scientific research would be revolutionized by faster-than-light travel capabilities. Astronomers could visit distant galaxies to study them directly rather than relying on light that has traveled for billions of years. Physicists could conduct experiments in exotic environments like the vicinity of black holes or neutron stars. The pace of scientific discovery would accelerate dramatically as researchers gain access to natural laboratories throughout the universe. The search for extraterrestrial life would be transformed by faster-than-light travel. Instead of listening for radio signals or looking for biosignatures in exoplanet atmospheres, we could visit potentially habitable worlds directly. The Drake equation, which estimates the number of communicating civilizations in our galaxy, would need to be completely reconsidered if faster-than-light communication and travel become possible. Contact with extraterrestrial civilizations would become much more likely if faster-than-light travel is achievable. The vast distances between stars currently make contact extremely difficult even if other civilizations exist. Faster-than-light travel would shrink the galaxy to a manageable size for exploration and communication, dramatically increasing the probability of encountering other intelligent species. The philosophical implications of faster-than-light travel would be profound. Our understanding of causality, free will, and the nature of time would need to be reconsidered. If effects can precede their causes, or if multiple timelines become accessible, the fundamental assumptions underlying human philosophy and ethics would be challenged. Religious and spiritual perspectives would also be affected by faster-than-light travel. Many belief systems are based on concepts of linear time, divine causation, and the uniqueness of human existence. The ability to travel faster than light and potentially encounter other intelligent species would require re-examination of these fundamental beliefs. The cultural impact of faster-than-light travel would be enormous. Human civilization has developed in isolation on a single planet, with all of our cultural, artistic, and intellectual traditions shaped by this experience. Contact with other worlds and civilizations would introduce new perspectives, ideas, and ways of thinking that could transform human culture in unpredictable ways. Education systems would need to be completely restructured to prepare people for a universe where faster-than-light travel is possible. Students would need to understand exotic physics, interstellar navigation, and cross-cultural communication with alien species. The skills and knowledge required for success in an interstellar civilization would be vastly different from those needed in our current earthbound society. The preservation of human culture and identity would become a major concern as faster-than-light travel enables the spread of humanity across the galaxy. How do we maintain connections to Earth and human traditions while adapting to life on alien worlds? The challenge of preserving cultural heritage while embracing cosmic expansion would require careful planning and consideration. Terraforming and planetary engineering would become much more feasible with faster-than-light travel capabilities. The ability to transport massive amounts of equipment and personnel between star systems would make large-scale planetary modification projects practical. Entire worlds could be transformed to support human life, creating new homes for humanity among the stars. The timeline for developing faster-than-light travel remains highly uncertain. Current theoretical understanding suggests that such technology, if possible at all, would require advances in physics that might take centuries or millennia to achieve. However, breakthrough discoveries could potentially accelerate this timeline dramatically, just as quantum mechanics and relativity revolutionized physics in the early 20th century. Research priorities would need to focus on understanding the fundamental nature of spacetime, dark energy, and quantum gravity. Experiments with exotic matter, if it can be created, would be essential for testing theoretical proposals. Advanced computer simulations would help explore the possibilities and limitations of various faster-than-light travel concepts. The research infrastructure required for faster-than-light travel development would dwarf current scientific facilities. Particle accelerators larger than the Large Hadron Collider would be needed to create and study exotic matter. Space-based laboratories operating in the vacuum of space would be essential for testing propulsion concepts that could be dangerous near populated areas. The international cooperation required would exceed anything humanity has achieved in scientific research. Theoretical breakthroughs in quantum gravity could provide the key insights needed for faster-than-light travel. String theory, loop quantum gravity, and other approaches to unifying quantum mechanics with general relativity might reveal new possibilities for manipulating space-time. The discovery of extra dimensions or the confirmation of certain quantum gravity theories could open pathways to superluminal travel that we can't currently imagine. The role of artificial intelligence in developing faster-than-light travel could be crucial. The mathematical complexity of exotic spacetime geometries and quantum field theories in curved space might exceed human computational abilities. Advanced AI systems could potentially discover new solutions to Einstein's equations or identify novel approaches to faster-than-light propulsion that human researchers might miss. Quantum computing could provide the computational power needed to simulate faster-than-light travel scenarios. The quantum mechanical nature of exotic matter and spacetime manipulation might require quantum computers to model accurately. As quantum computing technology advances, it could become an essential tool for designing and testing faster-than-light propulsion systems. The energy infrastructure required for faster-than-light travel would need to harness power sources beyond anything currently available. Fusion reactors, antimatter engines, or even more exotic energy sources would be necessary to provide the enormous power requirements. The development of such energy systems would have revolutionary implications for human civilization, even before faster-than-light travel becomes possible. Space-based manufacturing would be essential for building faster-than-light spacecraft. The exotic materials and precise construction required would likely be impossible to achieve in Earth's gravity well and atmosphere. Orbital factories and asteroid mining operations would provide the resources and facilities needed for constructing interstellar vessels. The testing phases for faster-than-light propulsion would need to proceed with extreme caution. Initial experiments might involve microscopic test masses or unmanned probes to verify theoretical predictions. The progression from laboratory experiments to full-scale spacecraft would require decades of careful development and testing to ensure safety and reliability. Robotic precursor missions could pave the way for human, faster-than-light travel. Unmanned probes could test propulsion systems, explore potential destinations, and establish infrastructure for future human missions. These robotic explorers could also search for signs of extraterrestrial life and assess the habitability of distant worlds. The first faster-than-light journeys would likely be brief test flights within our solar system. Traveling to nearby planets or asteroids at superluminal speeds would allow engineers to test systems and procedures without the risks associated with interstellar travel. These local tests would be essential for validating the technology before attempting journeys to other star systems. Interstellar navigation would require completely new approaches to spacecraft guidance and control. Traditional navigation methods based on celestial mechanics wouldn't apply to faster-than-light travel. New techniques using quantum entanglement, exotic matter interactions, or higher dimensional geometry might be necessary to navigate accurately across interstellar distances. The selection and training of faster-than-light travelers would involve unprecedented challenges. Crew members would need to understand exotic physics, operate in environments where normal intuition fails, and potentially interact with alien civilizations. The psychological screening would need to identify individuals capable of handling the unique stresses of superluminal travel. Emergency procedures for faster-than-light spacecraft would need to address scenarios that have no precedent in human experience. What happens if a warp drive malfunctions and traps the crew in a region of distorted space-time? How do you rescue travelers who become lost in a wormhole network? These questions would require entirely new approaches to space safety and rescue operations. The biological effects of faster-than-light travel on human physiology remain completely unknown. The exotic fields and forces involved could affect cellular processes, genetic expression, or neural function in ways that we can't predict. Medical research would need to study these effects extensively before human, faster-than-light travel becomes safe. Radiation protection would be crucial for faster-than-light spacecraft. The interaction between exotic propulsion fields and cosmic radiation could create new forms of dangerous radiation that don't exist in normal space. Shielding systems would need to protect against both conventional radiation and exotic particles created by the propulsion system itself. The psychological preparation for faster-than-light travel would require new approaches to mental health and crew training. Travelers would need to cope with experiences that challenge fundamental assumptions about reality, time, and causality. Support systems would need to help crew members maintain psychological stability in environments where normal human experience provides no guidance. Communication protocols for faster-than-light missions would need to account for the possibility of temporal paradoxes and causal loops. If faster-than-light travel enables communication with the past, strict protocols would be necessary to prevent paradoxes that could destabilize the timeline. The implications for free will and determinism would be profound. The establishment of interstellar colonies would become feasible with faster-than-light travel, but it would also create new challenges for human civilization. How do we maintain unity and cooperation across multiple star systems? What happens if colonies develop different cultures, values, or even different forms of government? The political implications of interstellar expansion would be enormous. Trade and commerce between star systems would create the first truly galactic economy. Resources that are rare on Earth might be abundant on other worlds, while Earth's unique biological and cultural products could be valuable throughout the galaxy. The economic opportunities would be vast, but so would the challenges of managing commerce across interstellar distances. The preservation of Earth's environment would become even more important if faster-than-light travel enables interstellar expansion. Earth would likely remain humanity's cultural and historical center, making its protection crucial for maintaining human identity and heritage. The planet could become a kind of cosmic preserve, protected from the industrial activities that might be necessary for interstellar civilization. Scientific collaboration across multiple star systems would accelerate human knowledge and understanding at an unprecedented rate. Researchers on different worlds could study unique phenomena and share their discoveries instantaneously through faster-than-light communication. The pace of scientific advancement would increase dramatically as humanity gains access to natural laboratories throughout the galaxy. The discovery of extraterrestrial life would be almost inevitable if faster-than-light travel enables exploration of many star systems. The implications for biology, evolution, and our understanding of life itself would be revolutionary. We might discover that life is common throughout the universe, or we might find that Earth's biosphere is unique and precious beyond imagination. Contact with intelligent extraterrestrial civilizations would present humanity with its greatest challenge and opportunity. How do we communicate with beings that might have completely different sensory systems, thought processes, or concepts of reality? The development of universal communication protocols and diplomatic procedures would be essential for peaceful contact. The potential for conflict with extraterrestrial civilizations would also need to be considered. While we hope that any contact would be peaceful, the possibility of hostile encounters cannot be ignored. Defense strategies and technologies would need to be developed to protect human interests while avoiding unnecessary conflicts with alien species. The transformation of human consciousness that would result from faster-than-light travel and contact with alien civilizations would be profound. Our understanding of our place in the universe, our relationship to other forms of life, and our cosmic destiny would be fundamentally altered. The psychological and spiritual implications would affect every aspect of human culture and society. The transformation of human consciousness would extend beyond individual psychology to reshape our entire species' worldview. For the first time in human history, we would truly understand ourselves as citizens of the galaxy rather than inhabitants of a single world. This cosmic perspective would likely diminish the importance of national boundaries, ethnic divisions, and other terrestrial conflicts that have shaped human history. The concept of time itself would need to be reconsidered in a universe where faster-than-light travel is possible. If causality can be violated and effects can precede their causes, our linear understanding of past, present, and future would become obsolete. Philosophers and scientists would need to develop new frameworks for understanding temporal relationships and their implications for free will and determinism. The nature of identity and consciousness would be challenged by faster-than-light travel, particularly if quantum entanglement or other exotic phenomena are involved in the process. If consciousness can somehow be transmitted or duplicated through quantum channels, fundamental questions about the continuity of personal identity would arise. Are you still the same person if your consciousness travels faster than light to a distant location? The possibility of parallel universes or alternate timelines accessible through faster-than-light travel would raise profound questions about the nature of reality itself. If multiple versions of history exist simultaneously, which one is real? How do we make moral and ethical decisions in a universe where every possible outcome might exist somewhere in the multiverse? Religious and spiritual traditions would face unprecedented challenges in adapting to a universe where faster-than-light travel is possible. Concepts of divine omnipresence, eternal souls, and cosmic purpose would need to be re-examined in light of new understanding about the nature of space, time, and causality. Some traditions might find validation in the discovery of cosmic interconnectedness, while others might struggle to maintain relevance. The arts and humanities would be revolutionized by faster-than-light travel and contact with alien civilizations. Literature, music, visual arts, and other forms of creative expression would be enriched by exposure to entirely new forms of beauty, meaning, and aesthetic experience. Human creativity would be challenged and inspired by contact with alien forms of consciousness and artistic expression. Educational systems would need to prepare students for a universe where faster-than-light travel is routine. Curricula would need to include exotic physics, interstellar navigation, xenobiology, and cross-species communication. The skills required for success in a galactic civilization would be vastly different from those needed in our current Earthbound society. The legal and ethical frameworks governing faster-than-light travel would need to address unprecedented questions about jurisdiction, responsibility, and rights. If actions in one star system can affect events in another through faster-than-light communication, who has authority to regulate such activities? How do we establish universal principles of justice that apply across multiple worlds and species? Environmental protection would take on new meaning in an era of faster-than-light travel. The ability to quickly transport materials and organisms between worlds could lead to biological contamination or ecological disruption on a galactic scale. Strict protocols would be necessary to prevent the spread of invasive species or diseases between star systems. The preservation of cultural diversity would become both more important and more challenging, as faster-than-light travel enables rapid communication and transportation between worlds. While contact with alien civilizations would enrich human culture, there would also be risks of cultural homogenization or the loss of unique traditions and perspectives. Economic systems would be fundamentally transformed by faster-than-light travel and communication. Traditional concepts of scarcity, distance costs, and market timing would become obsolete when goods and information can be transported instantaneously across interstellar distances. New economic models would be needed to manage trade and resource allocation in a galactic economy. The concept of citizenship and political representation would become complex in a civilization spanning multiple star systems. How do you maintain democratic governance when constituents are scattered across dozens or hundreds of worlds? New forms of political organization would be necessary to manage the affairs of an interstellar civilization. Military strategy and defense would be revolutionized by faster-than-light capabilities. Traditional concepts of borders, strategic depth, and defensive positioning would become meaningless when attacks can be launched instantaneously from anywhere in the galaxy. New approaches to security and conflict resolution would be essential for maintaining peace in an interstellar civilization. The role of Earth in human civilization would evolve as faster-than-light travel enables the establishment of colonies throughout the galaxy. While Earth would likely remain humanity's cultural and historical center, its political and economic dominance would diminish as other worlds develop their own capabilities and resources. Scientific research would be transformed by the ability to conduct experiments and observations throughout the galaxy. Phenomena that can only be studied near black holes, neutron stars, or other exotic objects would become accessible to researchers. The pace of scientific discovery would accelerate dramatically as humanity gains access to natural laboratories throughout the cosmos. The search for the ultimate nature of reality would be aided by faster-than-light travel capabilities. Questions about the fundamental structure of spacetime, the nature of consciousness, and the origin of the universe might be answerable through direct exploration and experimentation in exotic environments throughout the galaxy. Medical research would benefit enormously from access to diverse environments and potentially alien forms of life. New treatments and cures might be discovered by studying how life adapts to different planetary conditions or by learning from alien biological systems. The diversity of life throughout the galaxy could provide insights into fundamental biological processes. The development of artificial intelligence would be accelerated by contact with alien forms of intelligence and by the computational challenges of managing an interstellar civilization. AI systems would need to be capable of operating across multiple star systems, communicating with alien species, and solving problems that exceed human cognitive abilities. Space exploration would shift from being humanity's greatest adventure to becoming routine transportation. The romance and danger of space travel would be replaced by the practicalities of interstellar commerce and communication. New frontiers would need to be found to satisfy humanity's drive for exploration and discovery. The concept of home would be redefined for humans living in an interstellar civilization. While Earth would remain humanity's ancestral home, individuals might be born and live their entire lives on distant worlds. The psychological and cultural implications of this disconnection from Earth would need to be carefully considered. The preservation of human genetic diversity would become important as populations spread across multiple worlds with different environmental conditions. Genetic adaptation to local conditions might lead to the divergence of human populations, potentially creating new subspecies or even separate species over long time periods. The management of information and knowledge would become crucial in a civilization spanning multiple star systems. How do you maintain accurate records and prevent the loss of important information when data must be transmitted across interstellar distances? New approaches to information storage and retrieval would be necessary. The coordination of activities across multiple star systems would require unprecedented levels of organization and communication. Time delays, even with faster-than-light communication, could create challenges for maintaining unity and cooperation across vast distances. New forms of governance and management would be needed. The psychological effects of living in an infinite universe where faster-than-light travel is possible would be profound. The knowledge that countless worlds and civilizations exist throughout the galaxy could be either inspiring or overwhelming. Mental health support systems would need to help individuals cope with the vastness and complexity of cosmic civilization. The psychological adaptation to cosmic scale would require new approaches to mental health and human development. Children growing up in an era of faster-than-light travel would have fundamentally different perspectives on distance, time, and possibility than any previous generation. Educational psychologists would need to understand how exposure to infinite cosmic possibilities affects cognitive development and emotional maturity. The concept of privacy and personal space would be challenged in a universe where faster-than-light communication makes instantaneous contact possible across any distance. The ability to communicate immediately with anyone, anywhere in the galaxy, could create new forms of social pressure and connectivity that exceed anything we experience with current technology. Social media and communication networks would evolve to accommodate faster-than-light capabilities, creating truly galactic communities where individuals on different worlds can interact in real time. The cultural exchange and information sharing would be unprecedented, but so would the potential for misinformation, cultural conflicts, and social manipulation on a cosmic scale. The entertainment industry would be revolutionized by faster-than-light travel and communication. Live performances could be broadcast instantaneously across the galaxy, while artists could collaborate in real time despite being separated by thousands of light years. New forms of entertainment might emerge that take advantage of exotic physics and alien perspectives. Sports and competition would take on new dimensions when participants can be located on different worlds. Galactic championships and competitions could involve athletes from dozens of star systems, creating new forms of international cooperation and rivalry. The logistics of organizing such events would require unprecedented coordination and planning. The tourism industry would be transformed beyond recognition by faster-than-light travel. Vacation destinations could include alien worlds, exotic astronomical phenomena, and artificial structures built in space. The economic impact of interstellar tourism could be enormous, but so would the environmental and cultural challenges of managing visitors to pristine or inhabited worlds. Archaeological research would expand to include the study of alien civilizations and their artifacts. The discovery of ruins, technology, or art from extinct alien species would provide insights into alternative paths of evolution and development. Human archaeologists would need to develop new methods for studying non-human cultures and technologies. The preservation of historical sites and artifacts would become a galactic concern as faster-than-light travel enables easy access to important locations throughout human space. Earth's historical sites would need protection from the potentially overwhelming number of visitors, while new sites of historical importance would emerge on other worlds. Language and communication would evolve rapidly in response to contact with alien species and the need for universal communication protocols. New languages might emerge that incorporate concepts and ideas from multiple species, while translation technologies would need to bridge gaps between radically different forms of consciousness and expression. The concept of expertise and specialization would be challenged by the vast scope of knowledge available in a galactic civilization. No individual could hope to understand more than a tiny fraction of the accumulated knowledge of multiple species and civilizations. New approaches to education and knowledge management would be essential. Philosophical schools of thought would emerge to address the unique challenges and opportunities of faster-than-light travel. Questions about the nature of reality, consciousness, and existence would take on new urgency when travel between parallel universes or alternate timelines becomes possible. Traditional philosophical frameworks might prove inadequate for addressing these cosmic questions. The role of chance and probability in human affairs would be complicated by faster-than-light travel, particularly if it enables access to alternate timelines or parallel universes. If every possible outcome exists somewhere in the multiverse, the significance of individual choices and random events would need to be reconsidered. Ethical frameworks would need to address the responsibilities that come with faster-than-light capabilities. If actions in one location can instantly affect events across the galaxy, the scope of moral responsibility would expand dramatically. New ethical principles would be needed to guide behavior in a universe where the consequences of actions can be immediate and far-reaching. The concept of natural versus artificial would be blurred in a universe where faster-than-light travel enables the manipulation of spacetime itself. If humans can create wormholes, warp space, or access parallel dimensions, the distinction between natural phenomena and technological artifacts would become meaningless. Environmental ethics would expand to encompass entire star systems and potentially the structure of spacetime itself. The environmental impact of faster-than-light travel could include permanent alterations to the fabric of reality, raising questions about humanity's right to modify the fundamental structure of the universe. The relationship between science and technology would be transformed by faster-than-light capabilities. The ability to conduct experiments in exotic environments throughout the galaxy would accelerate scientific discovery, while the technological applications of new knowledge would have immediate practical implications for interstellar civilization. Quality of life would be redefined in a universe where faster-than-light travel makes any location instantly accessible. Traditional factors like climate, geography, and natural resources would become less important when individuals can easily relocate to worlds with optimal conditions. New measures of well-being would be needed for cosmic civilization. The concept of scarcity would be challenged by faster-than-light travel and access to the resources of multiple star systems. While some resources might remain rare even on a galactic scale, the ability to quickly transport materials between worlds would eliminate many forms of scarcity that currently drive economic and political conflicts. Population dynamics would be fundamentally altered by the availability of unlimited living space on countless worlds throughout the galaxy. Traditional concerns about overpopulation would become obsolete, but new challenges would emerge related to maintaining genetic diversity and cultural continuity across vast distances. The pace of social change would accelerate dramatically in a civilization connected by faster-than-light communication. Ideas, innovations, and cultural movements could spread instantaneously across the galaxy, creating rapid social evolution that might be difficult for individuals and institutions to adapt to. Innovation and creativity would be stimulated by exposure to alien technologies, perspectives, and ways of thinking. The cross-pollination of ideas between different species and civilizations could lead to breakthroughs and discoveries that would be impossible for any single species to achieve alone. The concept of progress would need to be redefined in a universe where faster-than-light travel enables access to civilizations that might be millions of years more advanced than humanity. Traditional measures of technological and social progress would become meaningless when compared to the achievements of ancient galactic civilizations. Risk assessment and management would become incredibly complex in a universe where faster-than-light travel enables rapid changes and unexpected consequences. The ability to quickly travel between worlds or access alternate timelines could create new forms of risk that are difficult to predict or prepare for. The insurance industry would face unprecedented challenges in a universe where faster-than-light travel makes traditional actuarial calculations obsolete. How do you calculate risk when travelers can access parallel universes or when actions can have instantaneous consequences across the galaxy? Emergency response and disaster management would require new approaches when faster-than-light travel enables rapid deployment of resources but also creates new forms of potential disasters. Natural disasters, technological failures, or conflicts could have immediate galactic implications requiring coordinated response efforts. The concept of retirement and aging would be affected by faster-than-light travel, particularly if it enables access to environments with different rates of time flow. Individuals might be able to extend their lives by spending time in regions where time passes more slowly, creating new approaches to longevity and life planning. The concept of retirement and aging would be revolutionized by access to regions of space-time where time flows at different rates. Imagine spending your golden years in a location where time passes more slowly, effectively extending your lifespan relative to the rest of the universe. This could create new social structures where different generations exist simultaneously at different temporal rates, fundamentally altering family dynamics and intergenerational relationships. Career planning would become infinitely more complex when faster-than-light travel opens up opportunities across multiple star systems and potentially different timelines. Traditional career paths would become obsolete when individuals can instantly travel to worlds where their skills are needed or where new opportunities exist. The concept of a stable, location-based career would give way to dynamic, galaxy-spanning professional lives. The nature of expertise would be challenged by the vast scope of knowledge available in a galactic civilization. Specialists would need to collaborate across species and star systems to tackle problems that exceed the capabilities of any single world or civilization. New forms of distributed expertise would emerge where knowledge is shared instantaneously across vast networks of researchers and practitioners. Educational institutions would need to prepare students for careers and challenges that don't yet exist. Universities might become galactic networks where students can attend lectures by alien professors, conduct research in exotic environments, and collaborate with peers from dozens of different species. The traditional model of campus-based education would be replaced by immersive, galaxy-spanning learning experiences. The concept of cultural heritage would expand to include the accumulated wisdom and achievements of multiple civilizations. Humanity would become part of a larger galactic culture while maintaining its unique identity and contributions. The challenge would be preserving what makes us human while embracing the broader cosmic community. Artistic expression would be enriched by exposure to alien forms of beauty, creativity, and meaning. Human artists would have access to new materials, techniques, and perspectives that could revolutionize every form of creative expression. The definition of art itself might expand to include forms of beauty that are currently beyond human comprehension. The concept of intellectual property would become complex when ideas and innovations can be shared instantaneously across the galaxy. How do you protect the rights of inventors and creators when their work can be transmitted faster than light to civilizations that might have different concepts of ownership and creativity? Scientific collaboration would reach unprecedented levels when researchers can share data and insights instantaneously across any distance. The pace of discovery would accelerate dramatically as scientists gain access to natural laboratories throughout the galaxy and can collaborate with alien researchers who might have completely different approaches to understanding reality. The nature of consciousness itself might be better understood through contact with alien forms of intelligence. Different species might have evolved entirely different ways of processing information, experiencing reality, and understanding existence. These alternative forms of consciousness could provide insights into the fundamental nature of awareness and intelligence. The concept of death and mortality would be challenged by faster-than-light travel, particularly if it enables access to alternate timelines or parallel universes. If versions of deceased individuals exist in other timelines, the finality of death might be questioned. New philosophical and religious frameworks would be needed to address these possibilities. The role of artificial intelligence would expand dramatically in a galactic civilization connected by faster-than-light communication. AI systems would need to manage the complexity of coordinating activities across multiple star systems, translating between alien languages and thought patterns, and solving problems that exceed human cognitive abilities. The concept of natural selection and evolution would be complicated by faster-than-light travel and contact with alien species. If genetic material and evolutionary innovations can be shared between species, the traditional boundaries of evolution would break down. New forms of directed evolution might emerge that combine the best features of multiple species. The nature of reality itself would be questioned in a universe where faster-than-light travel enables access to alternate dimensions or parallel universes. If multiple versions of reality exist simultaneously, which one is fundamental? How do we make sense of existence when infinite possibilities are accessible? The concept of home would be redefined for individuals who can instantly travel anywhere in the galaxy. Traditional attachments to specific locations might weaken as people become truly cosmopolitan citizens of the universe. New forms of identity and belonging would emerge that transcend planetary boundaries. The role of government and political institutions would be challenged by the need to coordinate activities across multiple star systems with potentially different forms of life and consciousness. Traditional democratic institutions might prove inadequate for managing the affairs of a galactic civilization with diverse species and interests. The concept of privacy would be fundamentally altered in a universe where faster-than-light communication makes instantaneous contact possible across any distance. The ability to communicate immediately with anyone, anywhere, could create new forms of social connectivity, but also new vulnerabilities to surveillance and manipulation. Economic systems would need to account for the unique properties of faster-than-light travel and communication. Traditional concepts of supply and demand, market timing, and transportation costs would become obsolete when goods and services can be delivered instantaneously across interstellar distances. The nature of conflict and warfare would be transformed by faster-than-light capabilities. Traditional military strategies based on geography, logistics, and timing would become meaningless when attacks can be launched instantaneously from anywhere in the galaxy. New approaches to security and conflict resolution would be essential. The concept of justice and law enforcement would become complex when crimes can be committed across multiple star systems with different legal systems and concepts of right and wrong. Universal principles of justice would need to be established that can be applied fairly across diverse species and civilizations. The role of religion and spirituality would evolve in response to the expanded understanding of reality that comes with faster-than-light travel. Some religious traditions might find validation in the discovery of cosmic interconnectedness, while others might struggle to maintain relevance in a universe where traditional concepts of space and time break down. The nature of love and relationships would be affected by the ability to maintain instant communication across any distance. Long-distance relationships would become more feasible, but the ease of travel might also make commitments more challenging to maintain. New forms of relationship and family structure might emerge. The concept of adventure and exploration would be redefined in a universe where any location is instantly accessible. Traditional forms of exploration based on overcoming distance and danger would be replaced by new challenges related to understanding alien cultures, navigating exotic physics, and exploring alternate realities. The role of chance and serendipity in human affairs would be complicated by faster-than-light travel, particularly if it enables access to alternate timelines where different outcomes occurred. The significance of random events and unexpected discoveries might be diminished if all possibilities exist somewhere in the multiverse. The nature of memory and history would be challenged by faster-than-light travel, especially if it enables communication with the past or access to alternate timelines. Traditional concepts of historical truth and factual accuracy would need to be reconsidered in a universe where multiple versions of events might exist simultaneously. The concept of personal growth and self-improvement would be expanded by access to alien perspectives and alternative forms of consciousness. Individuals might be able to experience reality from completely different viewpoints, leading to forms of personal development that are currently impossible to imagine. The role of tradition and cultural continuity would be challenged by the rapid pace of change enabled by faster-than-light communication and travel. Maintaining cultural identity and values would become more difficult when exposed to the vast diversity of galactic civilization. The nature of creativity and innovation would be stimulated by exposure to alien technologies, art forms, and ways of thinking. The cross-pollination of ideas between different species and civilizations could lead to breakthroughs that would be impossible for any single culture to achieve alone. The concept of success and achievement would need to be redefined in a universe where the accomplishments of ancient galactic civilizations dwarf anything humanity has achieved. New measures of progress and success would be needed that account for humanity's place in the broader cosmic community. The concept of success and achievement would require complete redefinition when humanity encounters civilizations that have had millions of years to develop technologies and wisdom beyond our current comprehension. Traditional human measures of progress, technological advancement, artistic achievement, scientific discovery, would seem primitive compared to the accomplishments of ancient galactic civilizations. This could either inspire humanity to reach new heights or create a cosmic inferiority complex that challenges our sense of purpose and value. The nature of competition would be transformed in a universe where faster-than-light travel enables instant access to the achievements and capabilities of countless civilizations. Human competitive instincts, evolved for small-scale tribal conflicts, would need to adapt to a cosmic arena where the stakes and possibilities are infinitely larger. New forms of competition might emerge that focus on creativity, wisdom, or contributions to galactic civilization rather than dominance or resource control. The concept of legacy and immortality would take on new meaning when faster-than-light travel enables access to alternate timelines or parallel universes. If versions of ourselves exist in infinite variations across the multiverse, the traditional desire to leave a lasting impact might be satisfied in ways we can't currently imagine. Alternatively, the knowledge of infinite alternatives might make individual achievements seem meaningless. The role of intuition and instinct would be challenged by exposure to alien forms of consciousness that might process information in completely different ways. Human intuition, evolved for survival on Earth, might prove inadequate for navigating the complexities of galactic civilization. New forms of decision-making and problem-solving would need to be developed that account for cosmic-scale challenges. The nature of wisdom and knowledge would be redefined in a universe where faster-than-light communication enables instant access to the accumulated learning of multiple civilizations. Traditional concepts of education, expertise, and intellectual authority would become obsolete when any individual can instantly consult the greatest minds in the galaxy on any topic. The concept of originality and uniqueness would be challenged in a universe where infinite variations of every idea might exist across parallel timelines or alternate realities. The human drive for creativity and innovation would need to find new expression in a cosmos where everything that can be imagined might already exist somewhere. The role of suffering and hardship in human development would be questioned in a universe where faster-than-light travel enables escape from any unpleasant situation. If individuals can instantly relocate to worlds with optimal conditions, the character-building aspects of overcoming adversity might be lost. New challenges would need to be found to promote personal growth and resilience. The nature of friendship and social bonds would evolve in response to the ability to maintain instant communication with anyone, anywhere in the galaxy. The traditional limitations of geography and time that shape human relationships would disappear, potentially creating new forms of social connection, but also new challenges for maintaining meaningful relationships. The concept of solitude and reflection would be complicated by the constant availability of instant communication and travel. The human need for quiet contemplation and personal space might be difficult to satisfy in a universe where isolation is nearly impossible to achieve. New approaches to mental health and personal development would be needed. The role of physical presence and embodiment would be questioned if faster-than-light travel enables forms of consciousness, transfer, or quantum entanglement-based communication. Traditional concepts of being physically present with others might become obsolete, fundamentally altering human social interaction and intimacy. The nature of commitment and responsibility would be challenged by the ease of escape enabled by faster-than-light travel. If individuals can instantly relocate to avoid consequences or obligations, traditional social contracts and moral frameworks might break down. New forms of accountability would need to be developed for cosmic civilization. The concept of scarcity and abundance would be revolutionized by access to the resources of countless star systems. While some forms of scarcity might persist, unique experiences, personal attention, or rare forms of matter, the traditional economic drivers of human behavior would be fundamentally altered. Post-scarcity economics would need to address motivation and purpose in a universe of unlimited resources. The role of leadership and authority would be complicated by the vast scope and diversity of galactic civilization. Traditional forms of leadership based on local knowledge and personal relationships would prove inadequate for managing affairs across multiple star systems with diverse species and interests. New forms of distributed leadership and collective decision-making would be essential. The nature of progress and development would need to be reconsidered in a universe where faster-than-light travel enables access to civilizations at every stage of development. Linear concepts of advancement would be replaced by more complex models that account for the diversity of evolutionary paths and the possibility of learning from both more and less advanced civilizations. The concept of destiny and purpose would be challenged by the infinite possibilities opened up by faster-than-light travel. If any future is accessible and every possibility exists somewhere in the multiverse, traditional concepts of fate and predetermined purpose would become meaningless. New frameworks for finding meaning and direction would be needed. The role of mystery and the unknown would be diminished in a universe where faster-than-light travel enables exploration of any location and potentially any alternate reality. The human drive for discovery and exploration would need to find new expression when traditional frontiers become instantly accessible. The nature of truth and reality would be questioned in a universe where faster-than-light travel might enable access to alternate timelines with different versions of history. Traditional concepts of objective truth would be challenged when multiple, equally valid versions of events might exist simultaneously. The concept of individual versus collective identity would be complicated by exposure to alien forms of consciousness that might not distinguish between individual and group identity in the same way humans do. New forms of self-understanding would emerge that account for the possibility of collective consciousness or distributed identity. The role of emotion and feeling would be challenged by contact with alien species that might experience reality in completely different ways. Human emotions, evolved for specific survival, and social functions might prove inadequate for navigating relationships with beings that have entirely different emotional landscapes. The nature of beauty and aesthetics would be expanded by exposure to alien art forms and concepts of beauty that might be based on senses or experiences that humans don't possess. Traditional human concepts of artistic beauty would be enriched but also challenged by contact with forms of aesthetic experience beyond current human comprehension. The concept of health and wellness would be revolutionized by access to alien medical knowledge and potentially different forms of biological organization. Traditional approaches to healthcare would be supplemented by treatments and perspectives developed by species with entirely different physiologies and lifespans. The role of work and productivity would be redefined in a universe where faster-than-light travel enables instant access to any resource or capability. Traditional concepts of labor and economic contribution would become obsolete when any task can be performed by the most capable individuals or civilizations in the galaxy. The nature of learning and education would be transformed by the ability to directly experience alien perspectives and forms of consciousness. Traditional educational methods based on information transfer would be supplemented by experiential learning that enables students to literally see reality through alien eyes. The concept of retirement and life stages would be complicated by access to environments with different rates of time flow and potentially different biological processes. Traditional human life cycles would be disrupted when individuals can experience time at different rates or access alien approaches to aging and development. The role of tradition and cultural preservation would become both more important and more challenging as humanity becomes part of a larger galactic community. Maintaining human identity and values would require conscious effort in the face of overwhelming exposure to alien cultures and perspectives. The nature of hope and optimism would be affected by the vast scope of possibilities opened up by faster-than-light travel. While the potential for positive outcomes would be infinite, so would the potential for negative consequences. New approaches to maintaining hope and motivation would be needed in a universe of unlimited possibilities. The nature of hope and optimism would be fundamentally transformed by the realization that infinite possibilities exist across the multiverse. While this could inspire unlimited potential for positive outcomes, it could also create existential paralysis when faced with infinite choices and consequences. Humanity would need to develop new psychological frameworks for maintaining purpose and direction when every conceivable future is theoretically accessible. The concept of heroism and courage would be redefined in a universe where faster-than-light travel eliminates many traditional forms of danger and sacrifice. Physical courage might become less relevant when individuals can instantly escape from threatening situations, while moral courage and intellectual bravery would become more important for navigating the complex ethical challenges of galactic civilization. The role of storytelling and narrative would evolve to encompass the experiences and perspectives of multiple species and civilizations. Human literature, film, and other narrative arts would be enriched by exposure to alien forms of storytelling, but they would also need to compete with narrative traditions that might be millions of years more sophisticated than our own. The nature of humor and entertainment would be challenged by contact with alien species that might have completely different concepts of what is funny, beautiful, or engaging. Human entertainment would need to find universal elements that can be appreciated across species boundaries while maintaining the unique perspectives that make human culture valuable. The concept of personal space and boundaries would be complicated by faster-than-light communication and travel capabilities. Traditional human needs for privacy and solitude might be difficult to satisfy when instant contact with anyone, anywhere, is possible. New social protocols would be needed to maintain healthy boundaries in a hyper-connected galactic civilization. The role of ritual and ceremony would evolve to incorporate the expanded understanding of reality that comes with faster-than-light travel. Traditional human rituals based on terrestrial cycles and local customs would be supplemented by new ceremonies that acknowledge our place in the cosmic community and our connections to alien civilizations. The nature of parenting and child-rearing would be transformed by the need to prepare children for a universe where faster-than-light travel is routine. Parents would need to help their children develop the flexibility, curiosity, and resilience needed to thrive in a galactic civilization while maintaining connection to human values and identity. The concept of aging and maturity would be complicated by access to alien perspectives on development and growth. Different species might have completely different concepts of what constitutes maturity, wisdom, or personal development. Human approaches to aging would be enriched but also challenged by exposure to alternative models of life progression. The role of memory and nostalgia would be affected by the ability to potentially revisit past events through faster-than-light travel to alternate timelines. Traditional human relationships with memory and history would be complicated when past events might be directly accessible rather than just remembered. The nature of forgiveness and redemption would be challenged in a universe where faster-than-light travel might enable access to alternate timelines where different choices were made. If versions of ourselves exist where we made better decisions, the significance of forgiveness and personal growth in our current timeline might be questioned. The concept of sacrifice and selflessness would need to be redefined in a universe where faster-than-light travel eliminates many traditional forms of scarcity and limitation. New forms of sacrifice might emerge that focus on giving up possibilities or experiences rather than material goods or personal safety. The role of faith and belief would evolve in response to the expanded understanding of reality that comes with faster-than-light travel. Traditional religious concepts might be validated by the discovery of cosmic interconnectedness, or they might be challenged by contact with alien spiritual traditions that offer different perspectives on existence and meaning. The nature of curiosity and wonder would be both stimulated and challenged by faster-than-light travel. While access to infinite possibilities would provide unlimited opportunities for discovery, the ease of exploration might diminish the sense of mystery and adventure that drives human curiosity. The concept of home and belonging would be redefined for individuals who can instantly travel anywhere in the galaxy. Traditional attachments to specific places might weaken as people become truly cosmopolitan citizens of the universe, but new forms of belonging might emerge based on shared values, interests, or experiences rather than geography. The role of patience and perseverance would be challenged by the instant gratification enabled by faster-than-light travel. Traditional virtues based on waiting, working toward long-term goals, and overcoming obstacles through persistence might become less relevant when any destination or outcome can be reached immediately. The nature of surprise and spontaneity would be affected by the predictability that might come with access to alternate timelines or parallel universes. If all possible outcomes exist somewhere in the multiverse, the element of surprise that enriches human experience might be diminished. The concept of uniqueness and specialness would be challenged in a universe where infinite variations of every individual might exist across parallel realities. The human need to feel special and unique would need to find new expression when countless versions of ourselves might exist throughout the multiverse. The role of struggle and adversity in personal development would be questioned in a universe where faster-than-light travel enables escape from any difficult situation. The character-building aspects of overcoming challenges might be lost if individuals can simply relocate to more favorable circumstances. The nature of commitment and loyalty would be tested by the infinite alternatives made available by faster-than-light travel. Traditional bonds of friendship, love, and community might be weakened when better alternatives are always instantly accessible. The concept of finality and closure would be complicated by faster-than-light travel, particularly if it enables communication with alternate timelines or parallel universes. Traditional human needs for endings and resolution might be frustrated in a universe where every story continues infinitely in other realities. The role of intuition and gut feelings would be challenged by exposure to alien forms of decision-making that might be based on completely different cognitive processes. Human intuition, evolved for specific terrestrial challenges, might prove inadequate for navigating the complexities of galactic civilization. The nature of wisdom and understanding would be redefined in a universe where faster-than-light communication enables instant access to the knowledge and insights of countless civilizations. Traditional human concepts of wisdom based on experience and reflection would be supplemented by direct access to alien perspectives and understanding. The concept of legacy and impact would be transformed in a universe where faster-than-light travel enables actions to have immediate consequences across vast distances. The traditional human desire to leave a lasting mark might be satisfied in new ways, but it might also be overwhelmed by the scale of galactic civilization. The role of solitude and contemplation would be challenged by the constant connectivity enabled by faster-than-light communication. The human need for quiet reflection and personal space might be difficult to satisfy when isolation becomes nearly impossible to achieve. The nature of creativity and innovation would be both stimulated and challenged by exposure to alien forms of art, technology, and thought. While contact with alien civilizations would provide unlimited inspiration, it might also make human creativity seem insignificant by comparison. The concept of progress and improvement would need to be reconsidered in a universe where faster-than-light travel enables access to civilizations at every stage of development. Traditional linear concepts of advancement would be replaced by more complex models that account for the diversity of evolutionary paths. The role of competition and achievement would be transformed in a universe where faster-than-light travel enables instant access to the accomplishments of countless civilizations. Human competitive instincts would need to find new expression in a cosmic arena where the possibilities and stakes are infinitely larger. The nature of love and relationships would evolve in response to the ability to maintain instant communication across any distance and potentially across different timelines or realities. Traditional concepts of romantic love, friendship, and family bonds would be enriched but also complicated by these new possibilities. The concept of death and mortality would be challenged by faster-than-light travel, particularly if it enables access to alternate timelines where deceased individuals might still be alive. Traditional human approaches to grief, loss, and mortality would need to be reconsidered in light of these possibilities. If you are still watching, make sure to subscribe to the channel and give a thumbs up. If you enjoyed this video, I am sure you will love this other one at the left side of the screen. This is why we would never survive on Mars. In this video, discover why Mars's thin atmosphere, extreme cold, toxic dust, and relentless radiation would overwhelm every system in your body and challenge even the most advanced technology. See you there.